Let's say we have this two-mass system, M1 on a frictionless track connected to M2 via a string over a frictionless pulley. We want to draw the free body diagram for each of these objects, and we want to find the acceleration in terms of M1, M2, and M3. So what we're going to do is, for M1, we have downward force of gravity acting at the center of mass, which is equal to m1g. We have also the normal force of this object from where it touches the ground, and that is going to just be straight up perpendicular to the ground. We also have the force of tension that is acting to the right, and you have no frictional force because this is a frictionless surface. So those are just the three forces that we are going to have. In this question, we are going to be considering this entire system of the table as our system for the problem. Now, for the hanging mass, we are going to have a downward force of gravity acting at its center of mass, m2g, force of gravity also equal to its weight, and acting upwards, we're going to have the force of tension. And those are the only two forces that we have. So now we have to decide the direction of the acceleration. So because we know the track is going to be frictionless, the hanging mass is going to pull down on the system. So what's going to happen after we let go, for example, M1 is going to accelerate to the right, and M2 is going to accelerate downward. So then we are going to have our magnitude of acceleration A. So because the string is taut and it doesn't stretch, both of the objects will have the same magnitude of acceleration because they're going to move together because they're attached by one string. So M1 and M2 have the same A. What you also know is that we can apply our Newton's second law to M1. So you have that the summation of your forces is equal to the mass times acceleration. So for M1, we can do our vertical direction first. We know that in the vertical direction for M1, that it is not going to be accelerating vertically because our acceleration in the vertical direction is 0. We also know this because the object is only moving in the horizontal direction. It's going to the right, not going through the table or flying above the table. There are no forces that are accelerating in either of those directions because those forces are going to cancel out. So we know the upward force is going to be N. The downward force is going to be M1G, which was our force of gravity. So that's all going to equal to 0. So then you can just add m1g to both sides, and if you do that, then that cancels out. You get that your normal force is equal to m1 times g. Now we can look at our horizontal direction. This is all for m1, by the way. So we know that in the horizontal direction, we have our horizontal forces will equal to the m1 times a. So because in the horizontal direction, all we have is the tension force, that is going to be in our positive direction, which was what we defined as our direction of acceleration. So that's equal to m1a. That's going to be the equation for the cart. Now we'll do Newton's second law for m2 as well. For m2, we are going to have the summation of our forces in the vertical direction. Those are going to equal to m2a. So we have m2g, our force of gravity, minus our tension, which is going to be acting in the opposite direction of our acceleration, is going to equal to m2a. That's your equation for your hanging mass. Now we can solve the two equations together. So from our cart equation, something important that you have to know is this tension force is going to be equal to one another. This is one string, and because it's one string, that means that T is equal to T because it's the same string that is pulling, and those tension forces are going to cancel out. So one force, we have Newton's third law acting here. So because that tension is going to pull M1 that way, it's also going to pull M2 that way as well. So they're acting in opposite directions. We already have the formula for tension from the Cart's equation right here. So we can actually take this and substitute this into our hanging mass equation right here. And if we do that, we get that M2G minus M1A is equal to M2A. After this, all you do is you add M1A to both sides. And if you add M1A, this would cancel out. We get M2G down here is equal to M1A plus M2A. So this will be allowing us to factor out A acceleration. So we have A acceleration times M1 plus M2 is equal to M2G. Now all you do is you divide both sides by M1 plus M2. So then you get that your acceleration is equal to your mass 2 times your gravity divided by your m1 plus your m2. So that is going to be the acceleration of the cart. So m1 is going to be your cart here, and it's accelerating to the right, and your m2 is your mass that is down here that's hanging, and that's accelerating downwards.